I've been working in the general area of pattern recognition, image processing, computer vision for the last 40 years. And, it just sort of happened, the serendipity, that in 1990, somebody called me from Washington, D.C. and said, you do good image processing work, and the NSA has designed or funded the development of FPGA processor. And we can give you this FPGA processing board, which is attached to a Sun, at that time, 350 workstation. And we can give you some money. Can you find some civilian application of this? Okay. So we thought about, as you know, FPGA is field programmable gate array. It can be reconfigured to do both low-level operations and high-level operations. So in the thinking in terms of the image processing domain, we said, what is it that we can do? So low-level operation is easy convolution. You look at a pixel, look at its neighboring pixels, and you can do either smoothing or edge detection, and that's some kind of a local filtering operation. For the high level, what could we do? Well, point matching is a generic computer vision operation. If you do stereo correspondence, you have left image, right image, and you take some landmarks in the two images and align them, and then estimate the depth. So we said, well, what will be the application of it? And this is where we just sort of said, well, fingerprint, because fingerprint matching is essentially a point matching operation. If you watch any crime show on the TV these days, CSI or anything, they will show you, computer extracting the minutiae points from a fingerprint and doing the matching. So it's really, fingerprint matching is essentially a point matching. And then the local operation, filtering operation, means fingerprint images, when they're captured, are generally of low quality, a little bit blurred, and so on. So we need to do some image enhancement of that. So that's how we really got started 25 years ago in fingerprint recognition. And I think now we have developed several technologies in fingerprint which has made some impact. And I think one of the best things which we have done is called texture-based fingerprint matching. Traditionally, fingerprint matching is based on points. But what happens if the fingerprint image does not have sufficient number of points, or the image quality is poor, that we cannot extract sufficient number of points? That's when you need to look at the texture, image texture formed by the ridges and valleys which characterize a fingerprint. So one of my PhD students, Anil, around 1999-2000, came up with a bank of filters which will capture the texture characteristics of a fingerprint. And that can be used for fingerprint matching. And surprisingly, not necessarily surprisingly, but to our delight, texture matching is what is used in the small sensors fingerprint sensors embedded in mobile phones. In order to have a small footprint of the fingerprint sensor which are embedded in mobile phone, and to reduce the cost, these sensors or fingerprint readers are about 80 pixels by 80 pixels. Traditionally, fingerprint sensors are 512 by 512 images of that size. So an 80 by 80 image captures only a small part of the fingerprint, not the whole fingerprint. And so if you capture only a small part of the fingerprint, the number of minutiae points in it is only maybe 4 or 5. And that's not enough to establish a correspondence between two different fingerprint impressions. So this is where the texture information is used. So I think, some of the work we did 25 years ago, 15 years ago or so, in terms of texture matching, is now seeing some renewed interest.
So look forward. What's got you curious now?
Well, so there are a number of interesting things we are doing. So for example, the traditional model of authentication or security for mobile space or any login which you do is log in once and then use it forever. But that was sort of revolved around the desktop computers. Now if you have a mobile phone, it's easily accessible by other people. So this notion of authenticate once and use forever is really not appropriate for higher levels of security. So that's why we have this nuisance built into the system where you unlock the phone, and after 5 minutes of not using it, you have to keep unlocking again and again. And a typical person may unlock a phone 40 or 50 times a day. Now, you are spending more time with the phone these days than with any other device. So why doesn't the device learn who you are based on your behavioral patterns, based on how you swipe the screen, based on how you hold it, GPS, and even the camera can turn on once in a while to capture your partial face image, and it knows, yeah, this is the owner of the phone. So this method is this mode of operation is called continuous authentication. So in the morning, you can present your frontal face image to the camera, get a strong authentication, or you can use a fingerprint, and then the rest of the day, unless the system is really unsure that it's not the owner, the system can just sort of keep it unlocked for you as long as it has a sufficient confidence that it's the owner of the phone. So that's one area which is quite attractive. The other area which is very interesting, and this applies to any biometric modality, whether it is fingerprint, face, or iris. These are the three most widely used body characteristics which are used for identification, is what is the persistence of these biometric traits and what is the uniqueness of the biometric trait. So if I have a 10-digit key or 10-digit PIN, I know how many distinct identities I can have, 10 to the power 10 or so. But can we say the same thing about, what can we say about fingerprint? How many unique identities can it discriminate? In principle, every finger has a different pattern on it. So there are 7 billion people, approximately 7 billion people living on the earth right now. So there are 70, assuming each one has 10 fingers, there are 70 billion fingers. So in principle, we should be able to discriminate, 70 billion individuals using this. But it doesn't work quite this way, because what is on the finger is maybe quite different from the impression of the finger which you use, or the image which you obtain to do the recognition. And this question of what is the individuality or what is the uniqueness of fingerprint or any other modality is not known. And this is something which we are working on. How do we establish the probability with which we can say that these two fingerprints are distinct, or the probability that your fingerprint will match one of my fingerprints? It is referred to as probability of false correspondence. And this notion is very important in the legal proceedings, especially when a person is convicted based on partial fingerprint found at the crime scene. And there have been a lot of innocent individuals who have been incarcerated because of the wrong testimony or wrong conclusions. So basically, we need to have some scientific basis for understanding what is the probability of false correspondence. The second fundamental premise of any biometric trait is the persistence. That is, does the fingerprint pattern change over time? Does the iris pattern change over time? We know that the people age, so the face characteristics changes over time. And it is indeed true that state-of-the-art face recognition systems start falling apart when the age separation between two images of the same person exceeds about 10 years or so. Okay. But in the case of fingerprint and iris, we have been led to believe that they last forever. But there is there's no scientific proof for that. And so just recently, last year, we conducted a study of about 20,000 individuals And the data came from Michigan State Police because, they are the ones who often encounter the same person again and again. And over a 15-year period, these 20,000 or so individuals had been arrested multiple times. So we have their fingerprint impressions on multiple encounters with the police. And we showed scientifically using a multi-level statistical models that fingerprint accuracy over this time period does not degrade. So those are the two important questions. The third important question is, if biometrics is going to replace passwords and ID cards, or used in conjunction with it, what happens if somebody steals your biometric traits? That means that the template or the representation of the fingerprint which is stored in the databases, whether it's in your mobile phone or whether it's in your local bank, how do we secure it so that that even if it is stolen, it cannot be used, or you can reissue a representation? That is, it's like a type of a credit card number which can be revoked, and then you issue the new credit card number. That is, I collect your fingerprint, but I never use the original version of it. I use some transformed version of it.